Welcome to this first breakout session. I hope you enjoy the keynote. My name is Julian. I'm a tech evangelist with AWS, focusing on AI and machine learning. And it's great to be back in London in this beautiful spring day. We're going to talk about machine learning. And I'm joined by Lars, the CTO of Lebara, a name you're certainly familiar with, who's going to talk about their use case in a few minutes. But let's get started. So who has never really done machine learning before? It's all right. I can raise my hand. I'm just faking it. OK. So this is pretty much what machine learning is all about, right? It's not just about algorithms and parameters and all kinds of weird techniques. It's actually engineering. It's a whole bunch of things. So you start from a business problem that you need to solve. You try to frame it into a machine learning problem, figuring out how data can help you solve that problem. And then you need to collect that data. You need to put it in a central place. You need to clean it, prepare it. Real life data is always messy and ugly, so there's a lot of work there. And then you move on to actually trying different algorithms, training models, experimenting, until you find a model that you like. That's good enough to solve your business problem. And then you deploy that model in production, and you have to live with that model in production 24/7 probably, monitoring it, scaling it, et cetera, et cetera. So when we talk about machine learning, we talk about the whole thing. We don't just talk about algorithms and data science. So the first step means, of course, collecting data. But in some cases, it does actually mean building data sets, okay? And in a lot of cases, building a data set is actually a very time-consuming and expensive task. Imagine you had to label images for autonomous driving models, okay? This is one of the more advanced applications out there, but any kind of image application, computer vision application, and even text, natural language processing application needs a data set to be labeled. So you would have to do this in the case of computer vision, right? So for every single frame, you would have to do this thing called semantic segmentation, assigning every pixel in the image to a specific instance. This is a car, this is a tree, this is the road, et cetera, et cetera. So imagine you have the right tools to do this. How long does it take you to do one of those images right? A few minutes, right? Once you've warmed up. Okay, imagine you need to do thousands of hours, right? Maybe more. It's an impossible task, okay? The same for medical images. Imagine you had to, highlight cancer cells, that kind of work. It's expert work. It's extremely time-consuming, and it's expensive as well. So we built a service called Amazon SageMaker Ground Truth that lets you annotate data set quickly. So we provide you with the tools, the actual graphical tools, to do image annotation, text annotation, and you can also build all kinds of workflows for other types of data. You can create workforces. So if you have experts in the company that know how to annotate this stuff, you can distribute the work to them. Or you could distribute it to third parties, AWS partners who have that expertise. Or you could distribute it to Amazon Mechanical Turk, where you could leverage up to 500,000 workers to work on your annotation workflows. Okay? And not only that, but we also add machine learning into the mix. So as humans start annotating data samples, in parallel, we automatically train a machine learning model. And as soon as that model becomes as accurate or more accurate than human annotations, then it starts labeling at scale. And so this saves you from a lot of human work, saving time and money. Okay, so SageMaker Ground Truth, lots of cool features. Check it out if you have annotation issues. Then, of course, you need to prepare the data. Okay, transform it, aggregate it, run ETL jobs, and whatnot. And here you'll find, a lot of, let's call them big data tools to do this on AWS. EMR, if you like, Hadoop, Spark, Redshift, if you need data warehousing, Athena, if you like serverless analytics, et cetera, et cetera. So that part is more about big data than machine learning. It's still very important. You need to get your data clean and ready to be trained. And then, of course, you need to deploy. So you could deploy using literally any of the compute services on AWS. If you're more of an EC2 person, then fine. You can deploy models on EC2, do everything yourself. If that suits you, that's okay. You could use container services like ECS or EKS, or a Kubernetes container service. If you're more of a Docker shop, then fine. You can absolutely build your own containers and deploy them on ECS and EKS. And if you just need batch, machine learning, batch prediction, then you could use AWS Batch, which is a batch service. I guess that's a good name for it. So all of these work, and they'll take you from training to deployment to scaling in pretty nice ways. To make your life a little easier, we have a collection of tools. So if you'd like to work with EC2, virtual machines, we've built a collection of AMIs, Amazon Machine Images, the actual binary files that are used to create virtual machines, to help you get started quickly with deep learning. Okay? So their so-called deep learning AMIs are just off the shelf. You can fire them up in one API call, and they come pre-installed with all those good libraries, optimized by AWS, so literally you don't have anything to do here. Just start that, get to work. Okay, they're free to use, you just pay for the underlying instance. And as of a couple of weeks ago, we also launched deep learning containers, which are exactly the same thing. So for now, we have a TensorFlow container, we have a MXNet container, more libraries coming soon, that you could use automatically off the shelf. They're hosted in AWS. Just grab them, run them on your Docker clusters, and save the trouble of building those containers. But I guess if you want to keep it simple, if you're more of a fully managed person, if you want to focus on machine learning and not on infrastructure tasks, then we've built this service called SageMaker. And SageMaker is really the simplest and easiest way to go from experimentation to training to deployment to scaling with the same service and the same SDK. So it really does cover all those steps. When you train on SageMaker, you have a number of options. Okay, fully managed doesn't mean boring or generic or inflexible. It's actually very flexible. So when you train, you have three options. You can use built-in algorithms. We have a collection of 17 machine learning and deep learning algorithms already implemented by AWS, just ready to go. Just a few here. And actually, Lars will talk about a few in a minute. These are ready to go, like I said. No machine learning coding required. Just configure the algo. No infrastructure work required because SageMaker is fully managed. So I'll show you a demo later in the session. You'll see we'll never worry about infrastructure at all. And you get all kinds of cool features like distributed training out of the box, pipe mode that lets you stream humongous data sets to instances, so there's really no limit to the data set size you can train on, et cetera, et cetera. So this is really the easiest and simplest way to get started. If you're already doing machine learning with libraries like TensorFlow, MXNet, scikit-learn, et cetera, we have those built-in frameworks. Okay, so again, pre-installed, pre-configured, optimized. So just bring your own code and train. Okay. And you can bring the exact same code that you would be using on your laptop. It's called script mode. It's a cool feature. I will demo it in the other machine learning session this afternoon. All these containers, because of course this is based on containers, are open source. So you can inspect them, you can customize them. You'll find everything on GitHub. You still have no infrastructure work to do, and you can still enjoy some of the cool features in SageMaker. And last but not least, if you need something else, okay, anybody using R? Oh, come on, there's got to be a few more. Yeah, you guys are hiding out there. Come on. I'm not going to make fun of you. It's all right. It's all right. R is very cool. C++ or anything else, okay? You know, any custom code that you wrote or your company uses and you want to train and deploy models with that, you can just create your own container. It's very simple to do and run it on SageMaker, okay? So it's a managed service, yes. It makes infrastructure transparent, yes. But it doesn't lock you into one specific framework or one specific way of doing machine learning. You can literally run anything that you like. And there's another cool feature launched at reInvent a few months ago called the Machine Learning Marketplace, where we have a collection of machine learning models built by AWS partners. Okay, and there are all kinds of things out there. And you can just grab them and deploy them on SageMaker. So this might very well save you from doing machine learning in the first place. So I really encourage you to take a look at those models. Okay, just look for Machine Learning Marketplace, and you'll find that. Okay, just like the EC2 Marketplace saves you from doing, from packaging third-party software, this Machine Learning Marketplace saves you from doing machine learning. So you can go home early and enjoy your life. And talking about enjoying life, let's bring Lars on stage. Come on, let's give him a round of applause. And he's going to talk about Lebara. All right, there you go.
Good morning, everyone. Nice to be here. As Julian said, I'm going to talk about machine learning at Lebara. To be honest, this is something we've only just started, so we're only on the beginning of this journey. But I think it fits nicely with what Julian was just explaining. We did something in a couple of days that already gave us very nice results. So what I'm going to be talking about, I'm going to tell you a bit about Lebara, who we are, and what we wanted to use machine learning for. So what we wanted to use it for is telco fraud. I'll explain that later. And using machine learning for that, and now and what our next plans are for this. So Lebara, we are a mobile virtual network operator. So basically we are a mobile operator. We don't have our own networks. We use the networks of other operators. Here in the UK, we use the Vodafone network. We are active in 5 countries across Europe. And we mostly target immigrants or global citizens. And our mission is to make it easier for people to communicate with their friends and family back home. As I said, we wanted to look at applying machine learning to telco fraud. Telco fraud basically is fraudsters trying to abuse telco products or services and trying to basically cheat us as an operator or our customers out of money. There's very many different ways of fraudulent behavior. I mean, I've listed a couple of them. One very common is SIM boxing. It's where companies, usually VoIP providers, try to terminate calls in a country by putting a lot of SIMs in a device, and basically that way they bypass any international connection fees. Usually national calls are cheaper than international calls. A way of finding out that a SIM is being used in a SIM boxing scenario would be that you have one number calling many different B numbers. Normally, any number, unless you're a small business or something like that, you would only call maybe 5, 6, 10 numbers. But in a SIM box scenario, you would see a lot of calls being made from a single SIM. Another example is revenue share fraud. And this is the scenario I'm going to be talking about in the rest of my presentation. Basically what happens is in revenue share fraud is fraudsters get these revenue share numbers, so basically 0900 numbers, numbers that allow them to cash out. Then they use SIMs that either have been topped up with, let's say, maybe a stolen credit card, or they find a way that maybe there's a problem with our numbering plan and we've maybe mispriced a certain destination. So a scenario like that would be, we would see a lot of calls from a lot of different SIMs to one A number or a set of B numbers, sorry. A special case of that is Wangiri fraud, and this is something where actually fraudsters do not make the calls themselves, but they set up calls to a lot of people, and then they hope that that our customers will call back to those numbers, not realizing that actually they're hitting a very expensive premium number. So how do we detect fraud today? Currently we have a rule-based system, and it works fairly well, but of course it's rule-based. So if people, if fraudsters find out what the rules are, they might find ways to get around those rules. And also, we don't know what we don't know. So maybe there's a lot of fraudulent patterns that we're not seeing today. So, we were thinking, can we use machine learning to improve our fraud detection capabilities? But then the problem is, we've only just started. How do we get up and running quickly with our limited knowledge? So what we did is we organized a 3-day workshop together with AWS, where they were kind enough to fly in some of their machine learning experts. And we worked with our own data, so real live customer data, our call detail records, which I'll tell you a bit more about later. And we created, using those call data records, a data set that was annotated using our existing rule-based system. Combined a bit with sort of the knowledge that our fraud team has. Basically we said, okay, we know who the fraudsters are. Let's tag all the data we have with, okay, this is a call made by a fraudulent SIM or to a fraudulent number. We focused, we split up in 3 groups. Each group tried to, detect a different kind of fraud using machine learning. As I said, I'm going to be talking about the revenue share fraud use case. And what we did is we used Amazon SageMaker to get up and running. So call detail records. So we have in our backend, we have something called an online charging system. And whenever someone makes a call or uses a byte of data or probably does a whole data session or sends an SMS or anything that can be charged, there's a CDR, a call data record, being generated in real time by that system. At Lebara, we take those CDRs and then we stream them using Kinesis and store them in S3 using Firehose, which is nice. So we already have the data accessible in a location that's easy for other AWS services to consume. So what does a CDR look like? So this is an example of one CDR. It's actually a call I made to my wife. As you can see, it's basically a CSV file, a CSV record, comma separated values, so the pipe delimited. And it's got a lot of information in here. But actually the only relevant pieces are, it is an A number, a B number, there's a duration, and there's a timestamp. And then there's a whole lot of other information basically saying, okay, which account was charged, is it, how much money was paid, etc. So we had these CDRs. So next step, as Julian was saying before as well, is we need to prepare the data. So we spent quite a lot of, as I said, we spent 3 days in a workshop with, let's say, 8 people. We spent a considerable amount of time preparing the data. So we had to clean up the data. There were some records in there which were not, they were not really calls to correct numbers. They were not numeric, or there were some weird characters in there. So we had to clean those out. We found out there was some really strange data in there in terms of very long numbers, for instance. And also what we noticed is if you look at, I've added a diagram at the bottom. On the left you see the data before it was cleaned up. On the right you see the after cleanup. Basically this shows a histogram of the number of calls for the time period that we looked at. The number of calls made to a number of a certain length. And as you can see, there's a lot of calls of like 5 or 6 number B numbers. And when we looked at them, we immediately found out, okay, these are calls to our customer services agents, to our top-up IVR, et cetera, et cetera. So we decided, this might, we know this is not fraud, and it might confuse our algorithm. So we decided, okay, let's remove those. So on the right, you can see the sort of the histogram of the cleaned up data set. And we did a couple of things like this, basically to get everything perfectly ready for our machine learning algorithm. So then we needed to extract some features from the data. So we know we were looking at, we wanted to look at revenue share fraud. So what you usually see is, fraudsters, they will try to do this at maybe in weekends or on Friday evening, or when there's a public holiday. So the time of the day and the day of the week is very, very relevant for this kind of fraud scenario. Because basically, fraudsters hope that, you know, if it's a weekend, no one is working and they can get away with it undetected. It's also relevant, as I said, the number of A numbers calling a certain B number. I mean, if you have, you know, just one number calling one B number, it's probably not fraud. But if you have a lot of different SIMs calling a specific set of B numbers, it might be indicative of fraud, unless maybe it's I don't know, it's a bank or I don't know, an insurance company or something like that. Then ratio of A to B numbers, so you know, just basically a factor of number of calls to some B number divided by the number of A numbers calling it, and the average call duration. As I said, you know, fraudsters will want to have these calls last as long as possible, and so they can make a lot of money, whereas a normal call maybe only lasts 2 or 3 minutes. Using the data set that we created, we decided to use 2 different models, machine learning models to test with. One is an unsupervised learning model. So basically we wanted to see, can we detect any anomalies in the data that we have? We used random cut forest for that. And it was actually quite interesting because I didn't expect this. So this uses the sort of untagged data. But we actually did find scenarios that looked very fishy. And when our fraud team looked at it, it turned out we had detected fraud within like, well, it was like second day of our workshop. So that was quite a big success for us. And then we started looking at you know, supervised learning, so with a labeled data set. I have to say it's quite a bit of a tricky situation because, you know, looking at the data set, only 1 in every 3,000 or 4,000 calls actually is can be considered a fraudulent call. The algorithm we use is XGBoost, and despite, you know, data being so, you know, unbalanced, we did manage to find some pretty interesting results. On the right, you can see the first, you know, after training our model, the very first results that we got, and as you can see, of the fraudulent cases that were in the data set, it managed to pick up about 1/3 of them easily. So, you know, next step for us is to do some tuning of our models to make sure that we detect more of our fraudulent cases. And for us, it's not such a big deal if actually we do catch some fraud which is not fraud, because you know, we have our own fraud team. They will look at all the cases anyway. So it's better for us to catch a bit more. So summarizing, I think using SageMaker, we were able to get started with machine learning very quickly without any prior knowledge. We've got some very promising results that we hope to, you know, continue building on, and yeah, that we really want to take into production. And we're also looking at applying machine learning in some other areas. And with that, I hand back to Julian. Thank you. Thank you very much. Thank you.
Okay. This is pretty cool stuff, right? Pretty cool stuff. I'm really, you know, we keep saying we want to make machine learning simpler for everyone, and this is a great example. Okay, just a few days of work, and you guys are even finding a fraud scheme that you didn't know about. So there you go. And obviously, the fraud examples that Lars gave are for educational purposes, right? Okay, so don't go and start ripping off people, please. Okay. So let's move on. So in this second section, I'd like to actually show you how to use SageMaker. So as always with AWS, everything's going to be based on APIs. And we actually built a specific SDK for SageMaker. And we call it the SageMaker SDK. It's a Python SDK. And it's very high level, as you will see. It's, if you're familiar with the typical AWS SDKs, they tend to be lower level, infrastructure level. But this one is really about machine learning. So the objects that we'll work with are, you know, algorithms and models and deployments, etc., etc. So it's good because it means you end up writing very little code, and you really need zero infrastructure knowledge, and you need very limited ML knowledge as well, because a lot of that stuff is already done for you. If you use Spark, there's also a Spark SDK for SageMaker in Python and Scala that lets you call SageMaker APIs from your Spark apps. Okay, I'm not going to cover that today. Ask me questions at the end if you want to. But the short version is the combination of Spark for ETL and SageMaker for machine learning and deep learning is very cool. Okay, that's my elevator pitch for it. Obviously, you can also use, oh, that's weird. Okay, we're missing a word, so PowerPoint weirdness here. It doesn't want to display. This should say AWS SDK. Okay. So obviously, we have a service level SDK, just like we have an SDK for Spark and EC2, not Spark, sorry, S3, EC2, RDS, etc. But this one, like I said, is more, it's more low level. It's really about managing lower level service APIs. So in the demo, I'm going to be using the high level SDK. Okay. So Lars mentioned using XGBoost, so I figured out, hey, let's continue on that theme. Okay, so I'm going to show you how to train and deploy and automatically tune a model based on XGBoost. Okay, so let's do this. Okay, can you read okay in the back? Yeah. Okay, yell at me if it's too small, okay? So I'm not going to do fraud detection here. I'm going to do marketing. So the idea here is that we have a data set, a historical data set, about 40,000 samples, telling us yes or no, did a specific customer accept a marketing offer, okay? And the goal here is to build a machine learning model that can successfully classify customers into two categories. Yes, they will accept the offer. No, they won't. Okay, so binary classification, and just like fraud detection is binary classification. Is this fraudulent? Is this not? And XGBoost is a good way to do this. Okay, it's one of the built-in algos. Okay, so I'll try to go. Yeah, we have time, so I'll try to go reasonably slow this time. So first, obviously, I need a development environment. Okay, so if you do machine learning already, or even if you don't, you know those notebooks, Jupyter notebooks are a super popular way to do this. So Jupyter is a web app that lets you easily write and run and experiment with Python code, okay? And this is actually part of SageMaker as well. We have a feature in SageMaker called notebook instances, which are fully managed instances pre-installed with Jupyter and all the libraries that I mentioned before, and you can just create them in minutes and open the notebook and get to work. Okay, so if you need dev and test environments, you can use those notebook instances if you like. Okay, so obviously I need to import the SageMaker SDK. I need to grab an S3 bucket because SageMaker needs training data to be hosted in S3, and it will save the trained model in S3 as well. Okay. So we need a bucket, so we can just grab a default bucket, that's okay. Next, I will download the data set. Okay, so here I'm downloading it from the internet to my notebook instance. Okay, and obviously we'd like to take a look at this. It's a CSV file, so looking at CSV files is pretty unpleasant unless you use this very nice Python library called pandas. Okay, so we can just import that file with pandas and display it. Okay, and now it looks reasonably nice. So we see the first 10 samples. We have about, I think we have 20, yeah, we can see 21. We have 21 columns, a little less than 42,000 samples, as you can see. And so we have 20 features that you can see here. And we have the target value that says yes or no, did that person accept the offer? Okay, so it's labeled, it's supervised learning, and we're trying to train a model that learns the patterns from this data. Okay? So interestingly, this is very unbalanced as well. Okay? We can count the number of yes and the number of no, and we see there's a ratio of about 1 to 8, which makes sense, right? So about eight times 8 people will say no for 1 people who say yes, who says yes, okay? So it's a problem in itself. We might have to work on it. Next, I'm going to do feature engineering, okay? So I'm going to skip that part because this is not a data science tutorial. And obviously, you will get the notebook and everything else. But in a nutshell, what I'm doing here is I'm encoding all the categorical variables like the jobs and a few more, the marital status and so on. I'm encoding those because we don't want to use with text strings. And we need to have proper categories. Okay, so for those of you who do machine learning out there, I'm using one hot encoding, and I'm getting rid of a few columns that don't make much sense. Okay, so once I've done that, I have a few more columns because I've exploded those categorical columns into individual columns. So if I have 10 different jobs, then I will have 1 column for each job. That's pretty much what I'm doing here. Okay. So dropping a few features, and then I'm ready to train. Okay. Again, don't worry. You'll get that notebook. You can look at all the details. Let's not get bogged down into data set preparation. Then I need to split the data set. Okay, and I'm splitting it in training, so to build a model, validation, to evaluate the model while it's being trained, and test to actually benchmark my model once it has been trained completely. Okay, so I split it, I save that into 3 different files, and all of that stuff is done locally on the notebook instance because this is such a tiny data set. If I was working with a terabyte of data, of course I would not do this on the notebook instance. Like I said earlier, I would probably use EMR or Athena or any scalable backend to do that transformation and pre-processing. Okay, but here, just 40K lines, I guess, are okay. Then I need to upload this stuff to S3 here, okay? Because again, like I said, data needs to be stored in S3 for SageMaker to pick it up, okay? So I'm uploading the training set in a specific location, the validation set, and the test set, okay? Then I'm defining those locations here. Okay, so this is CSV format. This is the location of the training set. This is the location of the validation set. And this is actually the information I'm going to pass to the training job. Okay? All right, so far we downloaded the data. We've done some cleaning, some feature engineering, split it, put it in S3, right? Now we're ready to do machine learning. So XGBoost is one of those built-in algos, okay? So I don't have to write a single line of machine learning code. The only thing I have to do is ask SageMaker to select the XGBoost algo. So that really means the XGBoost container in the region I'm running in. Okay, and this is what you see here. Okay, just give me the container name for the region I'm running in. So this is probably the Dublin region here. And I want the XGBoost algo, please. Okay, that's it. Okay, so now I know what container to use. And then I can configure my training job just like this. Okay, remember we said SageMaker is fully managed. It makes infrastructure disappear. Okay, that's what I'm talking about. So we use this SDK object called the estimator, which is the generic object for training jobs on SageMaker, passing the container, okay, so which algo am I actually using here? And importantly, how much infrastructure do I want to train on? So here I want to train on one M4 2XL instance, okay, which is more than enough for 40,000 lines. I could use something smaller even. Okay, and then where to save the model in S3, and the rest are just technical parameters we can ignore for now. Okay, if I had a huge data set and I needed to train on 100 instances, why not? I would just say that, right? That's it. That's all it takes. Okay, and this applies to built-in algorithms, built-in frameworks, TensorFlow, etc., etc. Okay, out of the box, you can just train on an arbitrary number of instances because SageMaker is fully managing all of them and taking care of distributing the training job. Okay, so infrastructure disappears. Okay, then I need to set hyperparameters. So, of course, Each of those built-in algos will have specific parameters. They're explained in the SageMaker documentation. XGBoost is actually an open source algo, so you can also refer to the open source documentation out there. The first parameter says, I want to do binary classification. Okay. The next two parameters say, hey, you're going to train for 100 rounds, but if accuracy has not improved in 10 rounds, just stop. Okay. So this is called early stopping. This helps, save time and money by not letting long-lasting jobs go for too long when accuracy doesn't improve. And that other parameter is actually scale pause weight. Is actually a way to rebalance things. Okay, so you can say, well, I've got 8 more times negative samples than positive samples. So please try and pay more attention to the negative cases by applying this multiplication factor. Okay? So I guess this is really, when you work with the built-in algos, this is really the only part where you, even if you have no machine learning experience, you need to read a little bit of the documentation and figure out what those parameters are. But initially, and I don't know if that's what you guys did, you can stick with the reasonable defaults, right? Stick with the mandatory parameters, and then keep tweaking, okay? So at this point, I could train and deploy, right? But there are a whole bunch of other parameters that could probably give me extra accuracy, okay? Like Lars mentioned, initially we can train those models very easily, but after a while we want to get the best performance, okay? So I could just go xgb.fit to train and xgb.deploy to deploy the model and start predicting, but I'm going to do one extra step in between, okay? We're going to use model tuning, okay? Also called hyperparameter optimization, or HPO. Okay? So the idea here is XGBoost maybe has 20, 25 parameters, and maybe 5 are really, really important in getting the best accuracy. So you could spend a day, a month, a life exploring those parameters, trying to get to the best value, okay? The value that gives you the best accuracy, or if, like me, you like to go home early whenever possible, you can use automatic model tuning and ask SageMaker to automatically find the optimal parameters, okay? So let me explain how this works. So here, let's say we want to optimize on those 4 parameters here, okay? And it really doesn't matter what they are, okay? Let's just say we know they're important in getting good accuracy from this algo. And we know by design, for example, ETA is between 0 and 1. Okay, by design, it's a floating point value. Mean child weight, okay, is a reasonable default is between 1 and 10, etc. So it's difficult to find the top values, but you could find the range that you want to explore. Okay, that's reasonable. Okay. Alpha is between 0 and 2, and max depth is the actual depth of the prediction tree built by XGBoost. And you could say, okay, 2 to 8 sounds reasonable. Okay, so let's try to explore that 4-dimensional space, okay, and find in that space the best performing model, okay? So what does it mean, the best performing model? It means the model with the highest metric, okay? And this metric in this case is called the area under curve. So AUC, sorry for the machine learning mumbo jumbo here, but for classifiers, it's a good metric to know if your model is predicting well or not. Okay, so we want to maximize that. Okay, so in a nutshell, we want to find the optimal set of those 4 parameters within those ranges that give me the maximum AUC. Okay, and again, you could spend your life doing this, but we're not going to spend our life doing this. We're just creating this hyperparameter tuner object, passing the estimator, the metric, the hyperparameter ranges that we want to explore, and how many jobs we want to run. Okay, so we're going to run 10 jobs, one after the other. And how does that work? Well, we run one job. Okay, so initially we pick random values for the parameters, and we run one job. And so we get 1 accuracy. And then, using that single data point, we apply machine learning optimization to literally predict what the next set of parameters should be, which one should be tried out. So it's not a random search like some people do. It's really, after each data point, we apply algos called Bayesian optimization and Gaussian process regression. Okay, you didn't want to know that, I know, but now you know. So machine learning algos that will actually predict where to look next in search of that maximum AUC. Okay, so we do this 10 times. And then we call fit, okay? And when we call fit, the job actually, the tuning job actually starts. Okay, and we can see those 10 jobs here. So each job is very short, as you can see. It takes about 1 minute, so the whole process took about 10 minutes or something, okay? And we see the individual jobs. And we see the AUC value, the accuracy value, not the accuracy, sorry, the AUC metric that was reached. And so we can see this one sucks, right? 0.5, okay? So a perfect classifier would be 1, okay, 100%. So we see some variability here as SageMaker explores and moves in that 4-dimension space in search of that optimal AUC, okay? And so we can see the best one. Okay, so you see the first one is not great, and then it kind of improves. Okay, and then we explore a little more just in case, but probably the best one is still the third one. Okay, so we could see the best training job, and you can see the parameters that actually gave us that high-performing job. Okay, so 10 is probably a little too low. I should probably run a few more jobs to explore a little more. But you know, I wanted this notebook to be very short to run, so you could just run maybe 20, 30 jobs and see if you keep converging to high-performing jobs. Okay, so of course we're happy with that, and we can just grab the best model. Okay, so we can find the name for the best model and we can deploy it, and it's as easy as calling .deploy. Okay, and saying how much infrastructure you want. Okay, so in this case, I want to deploy on one M4XL instance. Okay, so this SageMaker will create that instance, create an HTTPS endpoint that I can invoke and predict with. Okay, so we could do that. Okay, so I can grab, let's try and run this. Okay, so here I'm grabbing 10 samples from my test set. Okay, so the first line is actually the sample. Okay, that I've with the engineered features, and the numerical value here is the actual prediction. Okay, so binary classification predicts a value between 0 and 1, and then you have to apply a cutoff value saying, by default, let's say anything lower than 0.5 is a 0, so it's a no. Anything higher than 0.5 is a 1, so it's a yes. Okay, and we can predict with that. Okay, so what we're doing here is calling an API to predict. What this really does is it HTTP posts that data to the endpoint. Okay, but you could do that in any of your favorite languages, Java, C++, etc., using the SDKs. Okay, but when experimenting, it's just convenient to use that API. Okay, and when we're done, we can just delete the endpoint. Okay, and stop paying. Okay, and I didn't mention anything about pricing because it's very straightforward actually. So for training, you just pay for what you use. So if you train on demand this XGBoost algo for, let's say, 1 minute, well, that's what you pay for, 1 minute. Okay, SageMaker creates the infrastructure, trains, takes it down automatically. So you will never overpay for training. You will never leave anything on that's not doing anything useful. Okay. So that's what you pay for, by the second for the actual training duration. For endpoints, you just pay for how long that endpoint has been up, right? And you take it down and up again if you need to, okay? So again, I'm doing it at very small scale here, but if we had 50 training instances and 20 instances backing this endpoint, it would be the exact same code. I would just say, give me 50 training instances and 20 instances to back the endpoint, okay? Nothing more. So how do you get started? So SageMaker is is actually part of the free tier, okay, which is a way for you to use AWS services for free for 12 months. So check it out if you want to literally experiment at zero cost. If you want to practice a little more, I would highly recommend that you check out the Amazon SageMaker examples repo on GitHub, which has a huge collection of notebooks showing you all the built-in algos and TensorFlow and MXNet and everything else. It's growing by the day. It's really great. And it's a good way to explore. If you want, this example I showed you is actually a very short version of a workshop I did at reInvent last year called EM3-321. So if you want the full 3-hour, 4-hour version, it's in there. Feel free to check my blog on Medium, and you can also grab some more notebooks and examples on GitLab. I want to thank Lars again. Thank you very much, Lars, for being with us today and sharing your use case. Thank you very much for attending. Enjoy the rest of the day.